Hey, in this video I want to introduce the different types of inheritance, and a large part of the video will focus on multiple inheritance, where we have a child class that derives from multiple parents. We are familiar with single inheritance at this point, where a class inherits from one base class. Okay, so class A, the base parent or superclass, and then class B, which is a subclass or child class of class A. So in other words, class B derives from class A. We also have hierarchical inheritance. This is where more than one class inherits from a single base class. In an example, class A again is the base class, and then class B derives from class A, but class D also derives from class A. That is a simple example of a hierarchical inheritance. We also have multi-level inheritance, and this is where a class inherits from a single class, which is also derived from another class. So in the example, we have class A as the base class again, and then class B and class C are subclasses or child classes of class A, so they both inherit from class A, but class B derives from class A, and class C derives from class B. Class A is considered a direct base to class B, but it is considered an indirect base to class C. The direct base is going to appear in the class declaration, where you specify the base class or what you inherit from, whereas the indirect base is not going to appear in that list. In the next section, I want to introduce multiple inheritance, which is where a class inherits from more than one base class. Let's say class C has two base classes or parent classes, class A and class B. Then class C derives from both class A and class B. There's an example of the syntax for that at the bottom of the slide. You have class, the class name identifier, the colon, and then a comma separated list. So we publicly derive from class A, comma, and we also publicly derive from class B. Here's a quick illustration for you on multiple inheritance. To the left we have the examples. We have class A and class B, and then class C is going to publicly derive from both class A and also publicly from class B. To the right we can see that class C is going to contain the members of class A and the members of class B, in addition of course to its own members, so the members that class C will have. You can already start to think of some of the problems and conflicts that you can have with this type of inheritance, and I'll show you a quick example next in Visual Studio. In this quick example I have struct A, struct B, and struct C. Now struct A and B will both have the member X. I'm just going to initialize X in struct A to 1, and in struct B I'm going to initialize X to 2. Then in struct C we have the member Y, and actually I'll just initialize that to some value as well, maybe 5. Struct C is going to publicly derive from both struct A and struct B. Okay, so we have the colon, public struct A, comma, this is a comma separated list, and then also publicly from struct B. In main I construct C, which is of type struct C, and what I can do is I can do this fine. I can do cout c.y, build and run, and that works fine. As you might expect, we get 5 printed out. But what happens if we want to access X now? c.x, for example, build and run, and we get an error. You might have thought about this yourself. Okay, this is going to be ambiguous. Access of X. This could be X in the base, so struct A, or it could be X in the base, struct B. So how do we solve that problem? Well, what we can do is we do C dot, and then we can qualify the name. Maybe we want to access X from the struct B. First we do C, the dot operator, because we want to access some member that is contained within the object C. Then we qualify that member, so we qualify by doing struct B, the scope resolution operator, and X. Control F5 to build and run, and this should print out 2, and that's what we get. I'll click over here to place a breakpoint, and then I'll run the local Windows debugger. I'll open my locals window. Okay, we have the C object. Click that drop down, and this will basically describe the structure of that object now, or what makes up that object. So I have the member Y that is initialized to 5, and I can expand these. We also have these two parts, struct A and struct B, because we derive from both of those. And for struct A, X is initialized to 1 by default. That's because we've defined it in that way. For struct B, X is initialized to 2 as we have it defined. And then we have Y, which is part of the struct C. Okay, so we have Y, and that is initialized to 5 as we have it defined. But the important thing to note is a struct of type C is going to contain both a part of struct A and a part of struct B, and it's going to contain those members, not just variables, but also member functions. I'll just stop that. You can see where the complexity comes in. This can be a bit complex and confusing, especially if you have really complex classes or structs. It may be best to avoid multiple inheritance and instead refactor that to make use of single inheritance instead, or maybe multi-level inheritance. Next, I want to talk about hybrid and multipath inheritance. Hybrid inheritance is when we have a combination of more than one type of inheritance, and then we also have multipath inheritance, and that happens in the case where a class is implemented using multiple inheritance, where its base classes have a common base class. A quick example, let's say class D derives from class B and class C. Right, we have multiple inheritance, but the catch is that class B and class C both derive from class A. That would be an example of multipath inheritance. Of course, from this you can see that multipath inheritance is a type of hybrid inheritance. You have an example of a hybrid or multipath inheritance. What we have is a derived class, in this case class D, with two base classes, publicly derived from struct B and from struct C, and then both struct C and struct B will publicly derive from struct A. Struct A has a member X, struct B Y, and then struct C has a member Z. For this example, struct D doesn't have any members, but okay, I'll click over here to place a breakpoint, and then I'll run the local Windows debugger again. I'll switch over to the locals window, and I'll click the drop down to expand that. And we can see now that the D object, so I have struct D in main. The object D has these parts. We have struct B and struct C, and both struct B and struct C have struct A as parts of those. You can see struct A forms part of the struct B, and then struct A here also forms part of struct C. Now remember, if I scroll up, struct A has that member X, so we'll have X twice here, and as part of struct B we'll have Y, and then as part of struct C we'll have Z. I'll stop that. So you can also have ambiguous errors with this, just like in the previous examples. We can do d.y, and that will be fine, because y is part of struct B. And we can also do d.z, because that's a member in struct C. But both struct B and struct C publicly derive from struct A. In other words, we have x twice. So what happens if we want to print out x instead of z or y? Well, we'll have to qualify the particular member that we want to access. So we can do d.struct_b x, and then if we build and run, that works fine. Prints out 1. Copy and paste that, and the same for C. Now I'll just change one of those. So I'll change the member x, which is part of the B struct part of that D object. I'll assign 55 to that. Okay, and then I'm going to print out the x member, which forms part of the struct B part of the D object, and also the x member, which forms part of the struct C part of the D object. We should get 55 and 1 printed out. Build and run, and that is exactly what we get, 55 and 1. So those are two different members. They form part of different parts of that object. Okay, so in that way you can have a member with the same name, but it has a different value because it's within a different scope or within a different part of that object. Or in the case of a function, the function may have the same name or identifier name, but the functionality may be different. I'll just scroll up again. This was a quick example of hybrid inheritance or multipath inheritance. One of the reasons why you would use multipath inheritance is because you cannot specify the same direct base class twice. In the list where you specify the base classes, or structs in this case, you cannot have the same name twice. Let's say I try and do struct B twice. If I hover over this, you'll get a duplicate base class name error. Try and build, and you'll get struct B is already a direct base class. Remember, I talked about direct and indirect base classes. I'll undo here. Now struct B is a direct base class to struct D, and struct C is also a direct base class to struct D, but struct A is an indirect base class to struct D. Okay, in this example, I'll start with a clean project other than my main function and the include IOStream and using namespace standard. And I want to start off by creating a new file, a header file. So I'll right click, add new item. I'll choose header file and I'll call that vector, vector.h, and I'll add that to my project. And then in that file, I'll just define a struct vector, and we have two members here, x and y. That is just for demonstration purposes. And I'm also going to define a constructor and a destructor, also just for demonstration purposes. I'll define the constructor and the destructor for the vector struct inline, so in the definition of the vector struct, and then I'll create a new header file, new item, header file. I'll call this character, so character.h, and I'll add that to my project. Remove all of this stuff. Sometimes you get all of that when you press tab. Now I can go and change this here. I change the class name to character and we get character, the constructor and destructor added for us by Visual Studio. I'll just add this health member that we can inherit. Whether that is private or protected depends on what you want to do. For right now, I'll just leave it as is. Now what I can also do is I can right click on character, for example, quick actions and refactoring, and then we can select create definition of character in character.cpp. And currently we do not have a character.cpp file. If I select this, Visual Studio will create a character.cpp file for us. Click that. See, we get this peek view again. I'll just close that off. I'll save that. And then I'll go to that character.cpp in my Solution Explorer. Double click on that. Of course, you can create this manually. I'm just showing you your options. And of course, this will plan include character.h. It will qualify the character constructor. I'll actually do something like this in here as well. The reason why I'm creating these printouts is I want to show you the order in which they will be invoked, so the constructors and the destructors, based on how they will be ordered in a base class list. And I can do something similar for the destructor, quick actions and refactoring, and create definition. I'll just go to that. You'll notice you'll often have to go and include IOStream to make sure that we can do these printouts. Okay, so I have character constructed and character destroyed for the constructor and destructor respectively. I'll just close that off. That is going to be it for the character class. To save all of these files, I'll make sure to click on Save All. Next, I want to use multiple inheritance. I'm gonna derive from character to create a player character. Go and right click on header files, add new item, header file. And I'll create player character.h. I'll add that. And I'll remove all of these. I'll move that all the way to the right before I have main. And I'll just switch things around a bit here. Okay, I want to derive from character now. I'll just make sure to remove those colons to make sure the constructor and destructor are correct. And now I'll go and add or include the character.h file using the quoted form as opposed to the angle brackets. Again, those are used for predefined files as I explained in the previous video. For our own files, we want to use the quoted include. So include character.h. Now this knows what character is, the character class is, so I am publicly deriving from that. Quick actions and refactoring, and I'll create a definition for that. Jump to that. Make sure the player character.cpp includes the player character.h file, and I'll just move that around a bit. Okay, I'll print that player character constructed in the constructor, and I'll go quick actions and refactoring, and I'll create a definition of the destructor as well, and I'll promote that to document. Player character destroyed. Okay, so we have the constructor and the destructor now for the player character. But we're not quite done with player character yet. I'm going to include the vector as well. So I'm going to pound include vector.h. This is the base class list. So for player character we have multiple inheritance. We inherit from the character class and the vector struct. You might be thinking, wait a minute, in previous examples we had vector as a member. In these examples, in player character for example, we had some vector member, but I'm doing this here purposely to show you that a class can inherit from another class or from a struct, because a class and a struct again in C++ are basically the same thing. Later on in the example we are going to change the definition of player character around a bit, but for now this should work fine. I'll switch over to main.cpp, and now I can go and create objects of type player character. If you want to, you can place that in a compound statement, and then the destructors will be called before this end of program statement that I have, but I prefer to leave it in this way because we know that when the program reaches this closing curly bracket following this end of program statement, then it's going to destroy the local objects, in this case player. Control F5 to build and run. Let's hope we don't have any errors. Notice the output that we get. First it constructs the character. So it's going to construct the character part of the player character object. Then it's going to construct the vector. And finally it's going to invoke the player character constructor. Then we have end of program, meaning we reach the closing curly bracket of the main function. And notice we get the reverse order of that. We get player character destroyed, vector destroyed, and character destroyed. We've talked about this previously, but as you can see this is a bit more complex with multiple inheritance, which is why I've decided to demonstrate this to you again. So notice again we have character constructed and then vector constructed. Alright, I'll go back to player character.h, and you'll notice the order of the base class list. First we have character and then we have vector. Let's go and I'll switch that around a bit. We have public vector and public character now. I'll build and run once more, and now we get vector constructed first, then we get character constructed, and then player character constructed, and once more we get the reverse for the destructor calls. A few notes on multiple inheritance again. On the order in which base classes are specified in the base class list. Constructor initialization is going to take place in the order in which the base classes are listed, whereas destructors are invoked in the reverse order of the listed base classes. If your class relies on one base part being initialized before another part, then the order of initialization will be important. And the same thing with your destructors. You may need a base part of the class to be present when another part is being destroyed. Then again, the order of the base class list is going to be important, because your destructors are called in the reverse order. So from left to right when you initialize, and from right to left when you destroy, or in other words, the destructors are going to get called from right to left. Moving on with our example in the player character.h file, let's say we want a vector as a member of this player character class. So instead of doing multiple inheritance, I'll do single inheritance, so I'll publicly derive from the character class, and then I'll go and declare a member vec of type vector. I'll just build and run and this will work fine. So we are no longer deriving from vector, this is now a member. But remember, we still have to include the vector.h file because we are creating a vector object right here. This is not a pointer or a reference. If this was a pointer like that, if you take a second and you think about some of our previous discussions, you'll notice that we now have an unnecessary dependency in this header file. Then I could remove that line right there, and then you can do a forward declaration class vector, and then you won't get an error. That forward declaration is handy if you want to do multiple vectors like this. But what you can also do is, if I remove this, you can do class like that, class vector vec, and that is similar to a forward declaration. Control B to build succeeded, it's best to do a forward declaration up here. As we had it before, class vector, in the case where you use it multiple times, and then only do this style when you use it once. A quick recap here on multiple inheritance. A class can derive from a class or a struct, or both. We talked about the order in which the initialization and destruction is going to happen, and when you want to take that into consideration, then pay attention to the base class list. There's a comma separated list where you specify the base classes. And we also talked about composition. And next I'm going to summarize for you the difference between inheritance and composition in a bit more detail. So here we do composition. This player character class is composed of these members, so we have this vector member and whatever other members you add in here. But it also inherits from character. Alright, so it is a character. A quick summary on inheritance versus composition. Public inheritance refers to an is-a relationship. We discussed that before. Composition, on the other hand, refers to a has-a relationship. You can see an example illustration to the right. And this is basically when a class is composed of other types. These can be the fundamental types such as integers, floats, and so on. But it can also be user-defined types, other classes, structs, or enumerations. Now in the example to the right, the player character owns or manages a vector. Thus a vector cannot exist without a player character. This is a simplification. We have some vector to keep track of our player character in a game world. But typically in something like Unreal Engine, you'll also be keeping track of the rotation and the scale. So again, this is just a simplification. Before we end this video off, I want to show you another example in Unreal Engine. Of course, this is not an Unreal Engine tutorial or lesson, but I want to show you another real-world example. I have the Unreal Engine editor open, Unreal Engine 4. I'll go to Window, Developer Tools, and then the Class Viewer. Now I have this drop-down, Actor. Now an actor is something that we can drag and drop into the world. I'll just dog that up there. An actor is something like this. You can left-click and drag and drop an actor into the world, and it can move around. I'll just undo that, undo, and I'll play this. So an actor that moves around is like this tree. Okay, it can move around, or like these apples that fall from the tree. Whereas a pawn is like this pedal at the bottom of the screen that I can move to the left and to the right with my keyboard, with keyboard input or mouse input depending on how you have it set up, and I can go and collect those apples. So again, the pawn is an actor, but it can be possessed, or in other words it can be controlled by a player or an AI. And of course as a player you're going to control that using the keyboard or the mouse. Alright, back to the class viewer. You have the actor at the top, and then if I scroll down, we have the pawn class. As I mentioned, this is the base class of all actors that can be possessed by players or AI. I'll click this drop down, and then you have a character class. Characters are pawns, so in other words a character is a pawn, and a pawn is an actor, but characters are special pawns or specialized pawns that have a mesh, collision, and built-in movement logic. So again, a character is a pawn, and a pawn is an actor. I have Visual Studio open, and this is the header file where I define the pawn, the A basket base. So basically the header for that pedal that I move to the left and to the right at the bottom of the screen. Now we can see this publicly derives from a pawn. Again, a pawn is something that can be possessed. I can right click on that, and then I can either pick definition or go to definition. Go to definition will open that file to the right, as we've seen before. That is go to definition. Peak definition will open up this peak window. We can scroll up and we can see the comments again. Base class of all actors that can be possessed by players or AI. And we can see that this a pawn class is derived from actor, publicly derived from actor, and also publicly derived from this class right here, nav agent interface. Now actor, remember, is simply something that we can drag and drop into the world. It has a position, a rotation, and a scale. We can move it around programmatically, but that also has a base class, so I can right click on that, pick on definition, and you can see we have the class a actor, and that publicly derives from something called UObject. Now UObject is a special Unreal Engine 4 class. It is the base class of all Unreal Engine 4 objects that is going to be it for this demo. I don't want to go too deep into Unreal Engine 4 because we have all of these macros and so on. So I hope you're excited about learning more about Unreal Engine 4 or Unreal Engine 5, which may be out at this point when you watch this video. And I definitely recommend that you play around with that, maybe try and build a small game, follow my tutorials on it. That will really help you get comfortable with C++. Alright, I hope this video was useful to you, and I'll see you next time.